Okay, so let's speak about a virtual work. Okay, and we want to find the position for equilibrium, knowing that P1 is equal to 30 pounds and P2 is equal to 30 pounds. And the spring is unstretched when so the delta 0 when theta equal 45 degrees, spring is unstretched. Okay, unstretched, stretched. Here we go. So let's use the left side for the free body diagram and the right side for the displacement. So our system is everything including the two links and the spring together. At A, we have two unknown, AX and AY, because it's a pin connection. At D, we have a normal force, ND. And there we have two force P that we know the value. So that's the first one. On the right, displacement at A. No displacement, so we will use A as the origin or axis X and Y for the displacement. D, the displacement of D, so if we push at E and C, the displacement of D will be just on axis D. So we don't need to take into account because it's perpendicular to ND. And P, so we need to take into account the displacement delta YE and delta YC. For we don't have no the link I consider no weight. Yeah, YC. We have a displacement on X for this one because it's moving to the right. Delta XC that we need to consider for the force of the spring. Because your force of the spring, so this point doesn't move, but this point move. So we need, oops, delta YC, yes, it's going to the right. So we need to consider also the force of the spring. That will be to the left. And to the right, we have a force of the spring too, but this force of the spring doesn't work because E stay vertical, stay aligned with the point A. So we need to take in account, let me put it in yellow, the delta YC for the force of the spring, the delta XC for the force of the spring, the delta YC for P2, the delta YE for P1. There. Oops. So let's write this delta U for all of them. Oh, let's write first delta YC, delta YE. So YE, so that's this distance. So it's equal to 2 feet plus 2 feet is equal to 4 feet time. We have an angle theta there, so this is sine theta. And it's positive. So the delta YE is equal to 4 cosine theta delta theta. And it's also equal to YC. YC the same. And now for axc, so axc it's equal to, so this is this distance. So it's equal to 4 to plus 2 cosine theta. So the delta axc is equal to minus 4 sine theta delta theta. Okay, so now let's write the principle of work and energy, the principle of work and energy, we'll see that soon. The principle of work, so we've got delta U for P1 plus delta U for P2 plus delta of U of the force of the spring is equal to 0. So P1, we have 30 times delta YE, so the 4 cosine theta delta theta, plus 30 times the 4 cosine theta delta theta, and plus the force of the spring, so plus the work of the spring. Work of the spring is delta YC and force of the spring. So let's write the force of the spring time minus 4 sine theta delta theta. And those two, the product should be negative. So P1 and P2 are doing positive work, and this one is going negative work. So let's keep just our sign like this. It's equal to 0. Okay. So we can remove the delta theta. And let's rewrite this. So we have 120 cosine theta 2 times plus the force of the spring is equal to K time. So this is okay. This is the distance S, delta S, that is equal to the new S minus S0. Okay, so K time S minus S0 time, so let's put the minus 4 in front, minus 4 times sine theta. It's equal to 0. Okay, oops. Can remove this one. So we have 240 cosine theta minus 4 times 200, so 800 times the S minus S0. How much was the S? It was for 45 degrees. It was given that the spring is unstretched when theta equals 45 degrees. That's now that we need this information. So the S is equal to, so that's 4, so 2 plus 2 cosine 45 degrees minus S0. How much is S? No, that's the inverse, sorry. So the new position S, that this distance, this is equal to 4 times the new cosine theta, right? This theta, that will be less than 45, minus 4 cosine 45 degrees when it was at S0. Because S0 was when the spring was in stretch at theta equal 45. Okay, so we have 240 cosine theta. Did I forget the sine theta somewhere? Yes, I forget the sine theta times sine theta is equal to 0. I forget the sine theta. So 240 plus, let's write this, 3000 cosine theta minus cosine 45 times sine theta, it's equal to 0. How do you define that? So first we can a little bit simplify the 240 and this one. If we want, we can divide everything by cosine theta, but that will not be so really easier. What we can do, so if we divide everything by cosine theta, we have 240 minus 3. Let's remove a 0 on both. So 24. I divide everything by cosine theta. 24 minus 320 cosine theta minus cosine 45 times tangent theta is equal to 0. Let's try in your solver with your calculator. Okay, so I use the solver and the calculator, and first answer for theta is, and I keep everything in degrees, so 16.6 degrees. And there's another answer, so you can try another axe close to, let's say, 45 to see if there's something a little bit bigger, and alpha enter again. And you also have another answer that is give us this theta equal 35.8 degrees. So there's two positions at equilibrium for this problem. It will be one with an angle theta that is equal to, this one looks maybe 35, 36, and one like this, at your point A, at your point A, and this one will be 17 degrees with the same P. So the virtual walk help us to find the position of equilibrium of those two links that are held by a spring, and when we apply a force P on there. That will be useful if we know, like, I don't know, we are putting a plate on top of these links, and we need to know the stiffness of the spring for this system. So that was the last example for virtual work. And that's your last video of statics for my class. Yay! I see you in class. Bye-bye.